Hi, today we're going to be learning how to solve absolute value inequalities. But we're going to start off with the warm-up on composition functions. So go ahead and get out a sheet of paper, write down the following 5 questions, and turn it in when you're done. We're going to talk about compound inequalities, and we're going to review the notation. This is your less than symbol. This is your greater than. This is your less than or equal to. This is your greater than or equal to. And this is your not equal to. We're going to translate the following into words. When you see the curly brackets and you see the colon, it means the set of all x's such that x is greater than or equal to 4. Here, we don't see a colon, but we do see it looks like one of the lines for the absolute value, but the notation is a little different, but it reads the same. The set of all y's such that y is greater than 2 or less than 7. We could say y is between 2 and 7. That's another way of saying it. We're going to talk about interval notation, symbols and their equivalents in sets and graphing notation. If you see a union, that's an or. If you see an intersection, that's an and. These are your brackets, closed brackets. You should see an equal sign if you're going to use a closed bracket. If you don't see an equal sign, you just see less than or you just see greater than, you're going to use your open circles, and these are your open parentheses. We introduced to you negative infinity on a graph, that's to your far left or down, positive infinity far right or up on a coordinate graph. Negative infinity to positive infinity, those are all the numbers, all real numbers. When to translate x is greater than 4. So if we start at 4, we can go from 4 to infinity. So this is another way of writing it in interval notation. 4 to infinity is the same as x is greater than 4. X is less than or equal to negative 5. In interval notation, negative infinity all the way to negative 5. Those are all the values included between negative infinity and negative 5. Well, 5 has a bracket on it because it's included, it has an equal sign. Negative infinity doesn't, and it will never have a closed bracket on it. The next one, all the values that are less than 0 go from negative infinity to 0. All the values that are greater than 3 go from 3 to positive infinity. All the values between 7 and 10, 7 is included, and it goes up to 10. Those are decimals, fractions, everything between 7 and 10. So let's look at our number line and figure out how to put these compound inequalities on one graph. So we're going to create a graph for each inequality, and we're going to simplify it into one graph with an inequality expression. So we already have our dots in our graphs on each number. Well, let's figure out how we simplify this. First one, x is less than 1. And x is greater than negative 2. So when we put it on one graph and remove all the circles, they overlap. So this is all real numbers. And another way to write all real numbers, negative infinity to positive infinity. The second one, we have a dot at 1 and a dot at negative 2. So x values that are less than 1 and x values that are greater than negative 2. Let's see what we got. We remove the dots, we bring one down. It's the part that's between those two. So when we write that, it's negative 2 is less than x, and x is less than 1. So it's the values between negative 2 and 1. If we wrote it in interval notation, we'll start at negative 2 and go to 1. Take a look at C. Negative infinity to negative 2, and also 1 to infinity. Okay. The next one, no solution. What in the world? How do we get no solution here? Well, x is greater than 1. So here's 1 right here. X is less than negative 2. Here's negative 2 right here. So I want the values, the numbers that fall in both categories. Oh, no numbers fall in both categories because you're either greater than 1 or you're less than negative 2. That's why it's no solution. Yay, we got it. Next one is x is less than 1 or x is less than negative 2. Well, if x is less than 1, here's 1, and x is less than -2, they are overlapping. So if I just say x is less than 1, we covered it, and we're good. So the interval notation would be -infinity all the way to 1. Last one, x is less than -2, because we want the values that are both less than 1 and less than -2. Where's 1? These values right here are less than 1, but we need values that are less than 1 and less than -2. So these values in here don't count. So only the values count that are less than -2. Awesome. We move right into solving absolute value inequalities. Steps on the side. However, same as absolute value equations, we isolate the absolute value. Once we get it isolated, we create 2 inequalities. One that looks like the original, and the other one where it is the opposite of the original. So we have 12 minus 3x, and on the other side we have -12 plus 3x. We go ahead and solve both of those inequalities, and we get x is less than 2 and x is greater than -4. So x is less than 2 and x is greater than -4. So if our 2 is here and our -4 is right here, yay, 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 then we know that those values are in the middle. So our interval notation would be from -4 to 2. Now we got to be careful with inequalities. So in our next one is the example in your book. When we get ready to isolate the absolute value and we add 8 to each side, we get -5 times the absolute value of 2x is less than or equal to -5. So we're dividing by -5. Anytime you divide an inequality all the way through by a negative, you have to flip the sign. So now our expression becomes 2x is greater than or equal to 1, whereas at first it was less than. We set that up with 2 expressions. 2x is greater than 1 and 2x is less than or equal to -1. We get x is greater than or equal to half and x is less than or equal to -1/2. So this is what it looks like. Break it down to one graph, break it down, and there we have it. We write it in set notation. X values such that x is less than or equal to -1/2, or x is greater than or equal to 1/2. We don't say and would be like the one above it because it's covered in the middle. When you go in separate directions, one's going to the right and one's going to the left, we're going to use our or statement. I have one for you to try. Yes, I do. Try this next one. Put it on note paper or sticky pad. Show all the steps, graph it, and turn it in. Thank you for listening.